Let us try to solve this example problem for kinematics in 2 dimension. The position of a squirrel running in a park is given by this function. R is equal to the quantity 0.280 meters per second t plus 0.0360 meters per second squared times t squared I plus 0.0190 meter per second cube times t cube j. So the questions are, what are the vxt, vyt, or v sub xt and v sub yt, the x and y components of the velocity of the squirrel as functions of time, and at time 5 seconds, how far is the squirrel from its initial position, and at time 5 seconds, what are the magnitude and direction of the squirrel's velocity. So binigyan tayo ng position function r. Ito yung function na yon. So if you'll notice, itong kulay blue, no? Ito yung x component ng position function. So this is the x component. At itong red is the y component of your position function. So we are asked to get the x and y components of the velocity of the squirrel as functions of time. Okay, so we are required to get the v sub x with respect to time and v sub y with respect to time, the x and y components of the velocity as a function of time. And second, we are asked to find the initial position. So let's say that the position, let's say this is r, the position of the squirrel at time 5 seconds, and third, we have to find the magnitude and direction of the velocity. Let's say v at time 5 seconds. So binigyan tayo ng position function para mahanap natin yung velocity, and then later on mahanap natin yung x and y components. Of course, we need to apply calculus. So integral or differential calculus. We are given a position function. So from our previous lesson, if we are given a position function, and we want to get the velocity from position, then we have to differentiate or derive from the position function. So going back to our equation, this is our equation. So for us to get the velocity function, we need to apply derivative. So let us try to solve for this problem. So vxt and vyt. Derive first the x component. So the x component, let's say x. Let's say x is 0.280 meters per second times t plus 0.0360 meters per second squared t squared. So by just applying derivative, because we know velocity sub x is equal to dx over dt. So applying derivative to our position function, we will arrive at, of course, understood that for the first term, this will have 1. So 1 times 0.280 is 0.280. Let's first disregard the unit para mas madali nating huwag tayong malito. So 0.280, tanggalin muna natin yung unit, times t times 1, then t is 1 minus 1, so this will become 0. So this will become 0.280 plus, we have exponent 2, so 2 times 0.0360 times t, because we'll subtract 1 to the exponent. So this is now the velocity function for just for the x component. Okay, so this is now your equation. This is now your equation for velocity x as a function of time. So we can still simplify this term, no? 0.0360, but this is already acceptable. So for dy, we apply the same process. Dy is dy over dt, and by applying derivative to the y component, this is the y component 0.0190 meter per second cube t cube. So we'll have the derivative of 0.0190 meter per second cube t cube over dt. So we'll have now Vy as a function of time will be equal to 3 times 0.0190. Disregard uli muna natin yung unit times so we have an exponent of 3. This will become t squared. So this is equal to 3 times 0.019. 3 times 0.019 is 0.057. 0.057 t squared. So this is now uh, your velocity function of y with respect to time. So this is now your letter A. For letter B, we are asked to find the um, position R of the squirrel at time 5 seconds. So, ibig na yung position function. We just have to substitute 5 to the time. Binigay na yung function eh. Ito yung function natin, di ba? 0.280 meter per second t times 0.360 meter per second squared t squared I and 0.0190 meter per second cube t cube j. So we just have to substitute the time 5 seconds to that equation because from our time function r is equal to the quantity 0.280 meters per second times t plus the quantity 0.0360 meters per second squared times t squared. So let's say that this is the x component of your r first. Let's say this is r. So substituting 5 seconds to this equation, we'll have 0.280 times 5 seconds plus 0.0360 times 5 seconds squared. So the answer will be 2.3 meters. But this is just the x component. Okay, but we still need the y component. Let's say ry, where ry is according to our equation is 0.0190 meter per second cubed. So 0.0190, the quantity 0.0190 meter per second cube, t cube. So by substituting 5 seconds to this equation, 0.0190 times 5 cube, the answer is 2.375. 2.375 meters. So we are just asked to get the position, then we just have to solve for r, where r is the square root of rx squared plus ry squared. So given now these values, we have the square root of 2.3 squared plus 2.375 squared for ry, then we'll have 3.3 meters. 3.3 meters. So this is now the initial position. But for the third required, we need to get the velocity at time 5 seconds. So we already have the velocity function. Velocity function are these two. Ito yung velocity functions. Then we'll just have to substitute 5 seconds to this equation. So for Vx, because V will be equal to the square root of Vx squared plus Vy squared. So let's get Vx. So Vx is 0.280 meters per second plus 2 times 0.0360 meters per second squared times t. So let's just substitute 5 seconds to this equation. 0.280 plus the quantity 2 times 0.00360 times 5. So Vx is equal to 0.64 meters. Vx is equal to 0.64 meters. Let's also solve for Vy. Now Vy, according to our function with respect to time for Vy is 0.057 t squared. 0.057 t squared. Again, substituting 5 seconds to this equation, 0.057 times t squared. The velocity as a function of time, the y component is 1.425 meters per second. So this is your Vy. So for us to get the velocity of the squirrel's position, V is equal to the square root of Vx squared plus Vy squared. So this is the square root of, let's just substitute this to our calculator. The square root of 0.64 meters squared plus 1.425 squared. So the answer is 1.56. So the velocity is 1.56 meters per second. But this is not the final answer because we still need to get the direction. Let's say the direction is theta, and we need to use tangent. Arc tangent of Vy over Vx. So theta, using the values that we get for Vx and Vy, arc tangent Vy, which is 1.425 over Vx, 0.64. So the angle is 65.81 degrees. 65.81 degrees. If we are to get the direction, since Vx and Vy is positive, therefore it is on the first quadrant. So this is 65.81 north of east. So our final answer for V, for the velocity of the squirrel at time 5 seconds, is 1.56 meters per second, angle 65.81 degrees north of east, or above the positive x axis. So this is our answer for the velocity. So for letter A, we have These answers for the velocity function as the velocity function with respect to time for the x and y components of the velocity. Then we get the position, the initial position of the squirrel at 3.3 meters, and the velocity of the squirrel at time 5 seconds. So this is how we solve a problem for kinematics in 2 dimension.